So, good morning. Last class what we have discussed that your data equal to pattern plus error, pattern plus error. So, how do we extract pattern? That was the issue. So, with respect to this we will discuss now what are the statistical approaches or statistical approaches to problem solving. Statistical approaches to problem solving. If you see the slide, you see that here we will start with practical problem, then this practical problem will be converted to statistical problem, and statistical problem will help us to generate statistical solution, and this statistical solution. So, if I say that first one is practical problem, second is statistical problem, third one is statistical solution, then this statistical solution must be practical enough. So, that is practical solution. Now, whatever solution you get, statistical solution is converted to practical solution and it should be checked whether the practical problem is truly solved or not. That is why this cycle, and if you see the slide, you see that it is a basically cyclic one, your practical problem, and that is the crux of the matter. If you find out the practical problem nicely, identify and define the problem nicely, because rest of the things are following it. So, then the statistical problem, then your statistical solution, and finally, the practical solution. So, many a times we falter in effectively defining the practical problem. Getting me? So, what is practical problem? How do we understand a practical problem? So, I have started with a small example in last class, that a small company in a city doing business primarily local at the local level, and the company is monitoring its profit and sales volume, and it is observed that absenteeism is quite high and there are machine breakdowns also, and in order to improve that business performance, marketing department is also established maybe recently, and then they want to check that how the marketing department is performing. Now, here what is your practical problem? If I go back to this slide again, what is the practical problem? The practical problem is, as I told you, that there is threat to profit and sales volume, high absenteeism and occasional to frequent breakdowns, and maybe the poor performance of the marketing department may not be, but I am assuming that the performance of marketing department is also not good. That means, the threat to how to overcome threat to profit and sales volume. If high absenteeism is causing lower profit and that what is the extent of that effect, then it is better for the management to take actions. Now, we will convert it into a statistical problem. If you really want to build a statistical problem from a practical problem, these are the few items or steps which you must follow. First one is identify variables of interest. In this example, profit, sales volume, percentage absenteeism, machine breakdown in hours and M ratio. These are the variables what we have identified. Now, identify response variables. Out of those variables, all the variables, what are the response variables? Now, here by response variable what I mean to say? By response variable we want to mean to say that these variables are affected by presence of other variables in the system. Getting me? In other words, what we can say? Dependent variable. So, y1 and y2 are response variable, they are dependent variable. Why? Because the absenteeism, machine breakdowns and M ratio can influence profit and sales volume. So, immediately the next objective is identify the explanatory variables and find out the dependence relationship. Getting me? For this particular problem, although it is little bit difficult at this moment, that why suddenly we are going for this dependence modeling, what are the different types of dependence modeling techniques are there, but you should not be what I mean to say, you should not be governed by the techniques. That is the one of the threats. Many times what happen, you know many multivariate techniques and you think that your problem will fit to that technique. Please do not do this. So, that is why here I have written in the finding the relationship y is function of x. We have not said that it is a linear relationship or nonlinear relationship or it is a regression or it is something some other way of doing things, it is nothing mentioned. So, you must be driven by the problem at hand. So, our problem at hand is threat to profit and threat to your sales volume, and so we got the response variables where we want to concentrate, and accordingly some the other explanatory variables mean which there are the variables which explain why there is variability in profit and variability in sales volume, and then function of y is fx. In statistical modeling, the variability is the crux of the matter, please understand. You must understand the variability structure. In case of one variable there is variance, in case of several variable there is variance and covariance, and in totality we say that is the covariance structure. So, that covariance structure this will give you the pattern. The pattern you want to extract, this will be given by the covariance structure. Okay. So, let us see the statistical problem here. The statistical problem is that variability in profit and sales volume. By variability we are saying that definitely there is high variability caused by x1 which is percentage absenteeism, x2 machine breakdown in hours and x3 M ratio. There may be linear relationships. So, now you are coming to statistics domain, so you have to assume something. There may be linear relationships. Any problem up to this? Do you have any query? Any query from your side? It is okay. This side? No problem? Yes? Then I want to show that we say that fine, there is your relationship, statistical way you can examine the relationship, and we also assume that their relationship is linear. Now, let us see then pictorially. If you see this particular figure here. What we have said that y 1 is affected by x 1, x 2 and x 3. What is y 1? Y 1 we have said y 1 is profit, correct. So, y 1 is profit, x 1 is percentage absenteeism, x 2 is breakdown and x 3 is machine hours. Okay. So, y 1 is profit, x 1, x 2, x 3 absenteeism and your breakdown hours and M ratio. Now, this is the linear relationship between y 1 and x 1, x 2 and x 3. You may be wondering that what is x 0 then? Okay. That x 0 is a constant value which will be later on in multiple regression you will be knowing that x 0 will be giving a value of 1. For all observation that one value will be given, and beta 1 0 will be the intercept, means irrespective of the effect of all those explanatory variable considered here, but there will be still some value for y and that will be determined by beta 1 0, getting me, but it you slowly you wait, later on we will see. But the sole purpose of this particular figure is that what I mean to say that y 1, if you want a linear relationship you can pictorially represent like this. Similarly, for sales volume also you can represent like this. In the pictorial representation, please keep in mind two things. First of all, the arrowhead is, see that it is suppose x 1 versus y 1, if you consider that the arrow basically starts from x 1 and ends with y 1 and arrowhead is at the y 1 level. So, that it simply indicates that y 1 is a dependent or affected variable and x 1 is the causal variable or explanatory variable. And another issue is this epsilon 1. Epsilon 1, that is basically some error component, as I told you that data has two parts, one is pattern and error. That apart from this error, the rest of the things are basically pattern, beta 1 0, beta 1 1, beta 1 2, beta 1 3, that will ultimately reflect the pattern. So, similarly for y 2, but for this particular company your y 1 and y 2, their sales and volume and your profit for the same month, that is simultaneously occurring. So, if you go by two different models, linear models, will it suffice? That is why what I have written that y 1 y 2 are measured simultaneously, they are covering also.
Sir, one question.
Please.
You said that there may be a linear combination of those variables. This is linear model. Now here epsilon 1 and epsilon 2 are noise terms. Let's say y1 can be linearly
Related.
dependent on x1, x2, x3.
Yes, yes.
Now there may be a bias term other than the noise.
That is x 0, beta 0 is that.
Like beta 1 p x p plus epsilon 1. So, what is this? Now, what I am saying now further that y 1 y 2 you are measuring simultaneously. Do you want to keep the structure intact while estimating, while modeling, What is the structure here? Both things you are measuring simultaneously. So, you see the next slide here, the next slide left one. So, what you are doing here, you are basically saying no, both are occurring simultaneously and they are multivariate observations only. So, what I want to keep them in one model. I will not go for two linear models, only in one linear model I will do this. Okay. But there is another problem. What is the other problem? Other problem is y1 is basically and y2, there may be relationship between the two. It may so happen that y1 may affect y2. So, that means that y1 is not only a dependent variable or response variable, it also becomes a causal variable or explanatory variable. It all depends on the situation. Suppose in your situation this is not the case, no problem, but many a times what will happen, you will find out that this type of structure is there. So, when such a structure is present in the practical problem, how can you ignore it? You cannot ignore it. That means, you have to keep the practical that behavior, real behavior intact and then find out the model, not the other way around. Find out a model, feed the data and accordingly you say that is the behavior of the system studied. It is not like this. Okay. So, actually what happened, there are few models, by saying these few models are I can say discussed pictorially. One is multiple regression, then multivariate regression, then path model. Later on we will see that what are all those things. Now, what is what purpose effectively, basically from statistical sense. I said that what are the purposes of multivariate modeling at the beginning, but from statistical sense what are the purposes? You see, what first purpose is description. Any model you build, it definitely describe what is the problem at hand and what are the purpose of that study and what are the different variables involved in this particular problem and what are the, how these variables are measured, how these variables I can say are stored or kept, what from what data source it is found out, whether it is a primary data, I mean you have gone and collected or you have taken from some other source. So, all those things are coming under description. Then this description part should be done ritually. In fact, everything should be done ritually. Descriptive part you should not falter, because this is the problem definition part. Then explanation. What is explanation? The relationships between the variables, amongst the variables. What is the relationship? That is coming under explanation. Then prediction. Okay. So, whenever we talk about any model, we talk about description of the problem, we talk about explanation of the relationships of the variables building, which is basically used to build the model, and prediction. Now, many models are not able to predict. So, that means in a model, if in any model, if the first two portion is missing, then that is not a model. You will just develop a structure like this, a schematic diagram like this and describe something and you will say it is my model. That is a description part only, that is not the model. You have to explain the relationship. That means here in this particular diagram, this is the description plus relation. Where is the relation? Relation is gamma 1, gamma 2 gamma 1 3, gamma 2 1, gamma 2 2, these are the relations. And without this gamma and beta values, this is only a description. If you use certain model which will give you all those beta gamma estimates, and then explanation is completed. Now, using this side, the left hand side plus the estimates of beta gamma and errors, if you predict some values for y 1 or for y 2, that is what is prediction. Any model,
Sir, here you have assigned some weights with say gamma 1, gamma 2.
this I understand the look, this is the first class, basically second lecture here. Now, this what I am trying to give you a pictorial view only here, the how this beta 1 gamma 1 or beta gamma 1 1 beta 1, all those things, I mean what is the issue and how it will be estimated, all those things will come slowly. In the subsequent lectures you will be knowing the estimation portion.
Now, my question is this, in earlier diagram there is the dependency between x1 and x2, but there no weights are assigned.
Where? This is the only diagram. This is the only diagram.
No, between x1 and x2 there is no weight, or between x1 and x3 there is no weight, or between x2 and x3 there is no weight.
Okay, okay, fine. I understand now. Your question is this one, this side. Actually, in this case, this is a representation of multivariate regression. Here we consider all these variables are purely independent, and in this model case, this is a pictorial representation of path model. Here we consider that the independent variable can vary, can co-vary. Getting me? But in reality, you will not find out that all variables are independent, truly independent. So, this is a better representation. Okay. Slowly, just if multicollinearity is a problem, then this is the case. Later on, after in few subsequent lectures, it is there. Okay. Now, what are the different multivariate models that will be discussed in this subject? Okay, so I have given you some idea of that what is multivariate analysis, what is multivariate statistical modeling, what do you mean by multivariate, and also different data types, and how practical problem can be converted to statistical problem, and in statistical domain what are the problems, and then there we will now we will see that there are different types of multivariate models, and primarily these models will be discussed in this subject. Okay. So, multivariate models are categorized into two broad groups, one is dependence model, another one is interdependence model. By dependence model we say that there are two sets of variables, one is response site or response variables, another is explanatory variables. Getting me? So, there are two sides. Explanatory variables are used to explain the response variables. So, that is what is dependence. That is the dependent structure. Okay. And interdependence is if you see this interdependence model, there is no response site, all variables are coming under one bracket. All variables under one bracket. What we mean to say? there is relationship definitely, but within the same set of variables. There is no categorization of that one set is dependent and variable or response variable, other set is explanatory variables. So, based on this concept, so there are dependence model, there are interdependence model. So, in dependence model, MANOVA is there, which is multivariate analysis of variance. Multivariate analysis of variance. Multivariate analysis of variance. I think all of you know that what is analysis of variance, that is ANOVA, and it is presumed that the ANOVA is known, then only MANOVA can be understood. Then multiple linear regression, then multivariate linear regression, then your path model, structural equation modeling is another component. In addition, logistic regression, discriminant analysis. There are many more dependence model, but in this sets of models, what is the basic picture is that we have two sets of variables, one can be affected by other set of variables, and we can build model like y equal to function of x. This type of relationship model we can build. Other sets, other group, that is what I say the interdependence model. So, under interdependence model case, there are principal component analysis, factor analysis, cluster analysis. Here we will not segregate the variables into dependent or independent side. We take everything as x, one set of variables, and then we want to see the covariant structure of these x variables. There are many x variables, and based on this structure, our primary objective in principal component analysis is reduction of dimensions. So, dimension reduction. Factor analysis, not only dimension reduction plus naming the factors. So, dimensional reduction plus naming the factor. In cluster analysis, we want to group the individuals, not the variables. Factor analysis and PCA, we basically group the variables. So, then we reduce the dimension, and in cluster analysis we will not group the variable, we will group the individuals or items or objects on which data is collected, and then we make several clusters. Okay, cluster 1, cluster 2, cluster 3. So, like this several clusters will be formed. Before that, because we will try to cover so many models, it may not be possible to cover all, but substantial number will be of models will be covered here. But before that, what the basics of multivariate statistics is very important, that will be covered. So, as far as the sequence of lecture is concerned, so after this next lecture we will be covering your univariate statistics, a few lectures on univariate statistics, followed by multivariate statistics. Okay. So, there may be few hours, let it be 4 hours or 5 hours, 4 to 5 hours of this univariate case, then multivariate statistics may be around 7 to 10 hours will be on multivariate statistics, and understanding of multivariate statistics is very important for all of us. Otherwise, you will not be able to explain the multivariate models. what are those models, why these, where from these model are coming, what is the utility of model, we will say many things and you will not be able to explain. So, the backbone for all those multivariate models what I have shown you just few minutes back is multivariate statistics. Under multivariate statistics there will be multivariate normal distribution, multivariate normal distribution, which we will be denoting like MND, and followed by that will be multivariate descriptive statistics, which covers primarily mean vector, covariance matrix, correlation matrix. So, under multivariate descriptive statistics we will be concentrating on this. Then under multivariate statistics the next issue is multivariate inferential statistics. Okay. So, under multivariate inferential statistics what are the things we will be covering? We will be covering, first is Hotelling T-square. Getting me? Hotelling T-square, then your that is confidence region and simultaneous confidence interval, confidence intervals, then your hypothesis testing. So, whatever you have learned in univariate statistics, that univariate inferential statistics, that counterpart in multivariate domain, that will be discussed up to hypothesis testing. Okay. And that in case of one population, in case of two population, all those things will be discussed there. And you will see later on that, as I told you, that multivariate, your multivariate normal distribution is the crux of the matter. So, univariate normal distribution all of you know, and that we will denote it like this, n mu and sigma square, where mu is the population mean, that population is characterized by one variable, that is x, and sigma square is the variance component, variance of the population with respect to x, and this one is 1 by square root of 2 pi of sigma square e to the power minus half x minus mu by sigma square, where your this x value lies minus infinity to plus infinity. Okay. It is visible. So, now what will be the multivariate counterpart of this? Multivariate counterpart of this, so normal distribution if you draw, you will be finding like this. This is your univariate normal distribution, which is known as probability density function, or other way we say f(x). This direction, x axis will be x variable and your y axis will be your f(x). So, you have to understand its multivariate counterpart, that will be very difficult one, it is not that easy. Suppose there are two variables x1 and x2, and then there will be joint distribution x1 and x2. So, what is the distribution? So, something like this, you will be getting a two dimensional picture when we talk about only two variables. When we talk about more than 2 variables, picture that is not possible to draw, but you have to think that there is some shape. So, that abstraction level of thinking is required for understanding multivariate normal distribution. And as I told you that multivariate normal distribution is very important, because all the models, almost all the models in multivariate statistical modeling subject follows multivariate normal distribution. Because if the data follows multivariate normal distribution, then what will happen, most of the test can be possible. You can measure the goodness of it with appropriate statistical distributions of the statistics what will be used in those models. Okay. So, you will know all those things, that mean vector, covariance matrix and correlation matrix like this. Now, with respect to this small company data, I think I have given you that the data is 12 into how many 6, 12 into 6 data was given. So, you have seen that the matrix also you have seen the data matrix. Now, if I ask you what will be the distribution of this, as there are 6 variables, getting me. So, it will be a 6 dimensional issue, and your joint distribution will be f x1 x2 to x6. So, how to get this distribution? So, you cannot work now in scalar domain like the univariate case, we have to go to the matrix domain, and as a result you will see that I have written under multivariate descriptive statistics few things. One is your mean vector, is coming into consideration. Second one is covariance matrix, third one is correlation matrix. Okay. So, we will be discussing this after univariate statistics. Once this will come, multivariate normal distribution and descriptive statistics is covered, we will go for multivariate inferential statistics, which we will basically discuss on the basis of Hotelling T-square. We will be using extensively the Hotelling T-square distribution. So, apart from this, I request all of you to do one more thing, that you please go through probability distributions. Little bit of this, because this knowledge is very important, all discrete and continuous as well as continuous. Because probability distribution will not be taught here. Okay, I will definitely bring some probability distributions, but I cannot explain each of the distribution. Okay. So, you have to go through this. Another issue in this subject is that statistical distribution, no, not statistical, sorry, that is sampling distribution. It is also a probability distribution, but it is related to a, that is probability distribution of statistics, probability distribution of, suppose one is a probability distribution of statistic, 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 or there will be statistics also, but actually statistic and these statistics, by statistics we are basically talking about a random variable. I will explain in a univariate as well as multivariate that based statistics case, that how this, what is the statistics, how it is a random variable, all those things will be discussed to you. Okay. Now, let us come back to this again, the introduction part, that I told you that multivariate analysis is purely for the, here for this particular subject here, it is for the practice people who will be using it for solving the real life problems. Now, by real life problems, what do we mean? Here are some illustrative examples. Quality control. Any idea about quality control? For example, you think that suppose in any Kharagpur area itself there is Tata Bearings, there is Tata Metallics. Now, Tata Bearing will produce the ball bearings, roller bearings, this component they produce. Now, this component has certain quality features, for example, the dimensions, for example, the strength. Now, customers we require the bearings, the product with certain quality features. These quality features basically converted into specifications. If you produced beyond specification, means not within the specification provided by the customer, what will happen? That product will be rejected by the customer. But if you want to see that why you are producing rejects, then you will find out that there is a problem with the process, manufacturing process. Now, manufacturing process variables will affect the product quality. So, it is the product quality variables will be the dependent side and process variables will be the independent side. You can model that product quality vis-a-vis process variables. Enormous examples of quality control issues are there published in the literature, okay, using statistical techniques. Second example, basically it is a service, one hotel room service case, service example. Suppose you see that that storage, that hotels are there, big hotels basically I am talking about. This hotel, they are basically providing service to many customers. So, now they also require some sorts of service quality management, otherwise impossible, because they will not yield to the profit they are interested in. So, there also lot of data is generated and you have to use those data and develop model and solve the purpose for which the model is developed, or the basically the hotel room service can be much better. Taste of medicine, another issue. Taste of medicine means every time, every month you will see that there is a different medicine coming for different diseases. For every single disease there may be 4 or 5 medicines are there. Now, my question is, how do I know that medicine works? Medicine A works for some group, medicine B may work for some other group, even though the same disease, or some medicine are performing better than the other medicine for the same disease. So, that type of testing is also possible using, if you collect proper data, it is possible. Now, vendor selection, it is a very tricky problem, very essential critical problem in almost all small, medium, large enterprises, because your vendor, the supplier's quality is very important. If you get poor items, poor raw materials supplied by your vendor, ultimately your product quality will suffer. So, how to go about it? What modeling can be possible there, so that you will select the best vendor? There are different ways of selection. Maybe someone may go for not statistical route, some other route, but statistics also, multivariate statistics also helps you in selecting vendor. Safety management. So, as I told you job stress few minutes back, there are many variables affecting the people's safety. I want to know that what are the variables affecting more and what are the variables affecting less, so that I can take appropriate actions which will improve the overall safety standards of the plant, of the shop floor, of the work, everywhere. Now, lean production. You see this lean production. Lean production means what is basically there. Suppose inventory control is a big issue. You are producing 10 items, but from raw material side you are keeping huge huge raw materials in inventory, it is a loss to the company. So, what you want? You want to minimize the inventory, but you cannot minimize inventory unless you have some steps taken, some buffer or something else is there through which you can satisfy the customer at the same time based on your production requirements. Now, lean production said that you minimize everything in such a manner that you will satisfy the customer, but as well as from inventory point of view there is also at the minimum level. Raw material inventory, work in process inventory, everything will be at the minimum level. There are very good models in our operation research area, but statistics also can be useful there. Now, damage during transportation, another one. You see that damage during transportation, it is a logistic problem. I will show you some, I think one tutorial I will give you later on, that how to model that damage part with respect to that what mode of transport you are using, what is the distance you are transporting, what type of packaging system you are using. So, all those things ultimately lead to damage, and it is a huge cost to the company, those who are basically supplying that product to the customers. Effectiveness of training. There is now question is that whether PPT based training teaching is best or class blackboard chalk and talk. There is question like that in the training in the industry level, that whether it is a basically classroom training or on shop floor training, what will be the teachers combination, faculty combination. So many issues are there. So, if you collect data effectively, you will be able to use multivariate statistical models to find out that which mode of training or which type of training is better. Marketing is an area where your statistics is used very much. For example, if you go through any marketing journal, you will be finding out that full of statistics. Many models comes from that side also. Marketing research, that is the area where you will be able to use statistics. By marketing performance, basically we have conducted one study to understand the purchase intention of customers, and we have used structural equation modeling there. Getting me? Structural equation modeling there. So, some illustrative examples, some other illustrative examples can be framed, but you are the person who knows your system, and please find out some case, some example from your workplace, your domain of expertise, so that whatever I will teach here, you will be able to translate to your own system. In administrative science, management science, social science, everywhere this multivariate statistics is used, and you have to find out all those things, and I will be giving one after another, and you just based on this my explanation and the things you will be learning here, you try to find out analogy to your system and develop accordingly, and then the learning will be complete. Otherwise, learning will become incomplete. You have to be very careful for this purpose. I will show you later on some cases, so that you understand that the totality, as I told you, that starting from practical problem to practical solution, that means practical problem, statistical solution, practical solutions. This total cycle will be completed using these our cases. This is first case is characteristics of accident involved and non-involved workers working in an underground coal mine. I told you that in safety management, I told you that one, that in safety management one of the issue is, one of the theories was there which is not now that much popular, but the theory is still working in that sense, that some people are inherently accident prone. Irrespective of the situation, they meet an accident, but some people are able to avoid accident. So, that is the issue, and then we started thinking that whether that people can be categorized as accident prone or not accident prone. Okay. So, there are 22 variables we have collected, and I will show you this case wherever it is required based on the need of the model that will be described. Then study of process quality, process variables as well as quality characteristics in a cast iron melting process, that is also a real case study like earlier one, that where we have that two sets of variables we considered, and we found out the relationship between the two sets, and based on this relationship how effectively the quality of melting process can be improved. Third one is job stress assessment for industrial workers. Okay. So, there are from officers to that shop floor, maybe your worker like mechanic or the someone who is doing welding. So, different job profiles are there, their responsibilities and roles vary, and accordingly what happened, they may suffer from different level of job stress. Okay. So, I will show you in that how the job profile as well as their demographic variables will affect the job stress, and you will see that what way it will be done, and the similar situation you will face in your work also. Then you will be able to just straightway translate this to your work. It is possible. Getting me? Any question? Because this is a purely qualitative one lecture, and but next class onwards it will be mathematical, and if you there are some I think you know, all of you know this, but there are some famous quotes for statistics. I will end today's now this lecture with these quotes. You know George Bernard Shaw, what he basically said, you see, it is the mark of a truly intelligent person to be moved by statistics. Okay. Now you know Mark Twain also, but what he says, there are lies, damned lies and statistics, the two different philosophy. Mark Twain is saying that do not believe in statistics, because statistics is the maximum liar at that level. But we believe in Edward Deming, because ultimately Edward Deming is the quality guru, that sense. He used statistics in the quality domain, quality management domain, and he showed that the statistics can do wonderful in improving quality in terms of totality of quality management. What he said, in God we trust, all other must bring data. If there is no data, I will not believe. Okay. So, what we can then summarize what you have learned today. So, today ultimately we started with, first is the definition of the word multivariate. Then we said that how statistical modeling will be useful. useful. And we also said that when we talk about multivariate, that multivariate observations needs to be carefully measured. You require careful measurement of multivariate observations, and you must be thorough about the data types like nominal data, your ordinal data, your interval data, your ratio data. If possible, you go by this order, means if possible collect ratio data. And we have seen also that ratio data and interval data are basically these two comes under this continuous, and first two come under discrete. But by discrete data we also mean, we understand also count data, that all please keep in mind. Okay. Then I show you basically that that multivariate analysis means you have to work in the domain of matrix, because x n cross p, that is what is our multivariate observation. And this one can be written like this, and there may be several your vectors like x1, like x2, like xp, where x1 denotes the first column all observations, x2 denote the second column of observation, these are the vector variable vector 1, variable vector 2, variable vector 3, that is very, very important for all of us. Okay. Then another thing what we said, that do not rely on technique, do not be biased with techniques. You go by problem, go by the need of the, by the need means what I mean to say, go by the problem, and you carefully define this, and that definition. So, that means you are basically going from practical problem to statistical problem, statistical problem to statistical solution, statistical solution to practical solution, then practical solution to this. And what you more you have understood here also, that you have understood that there are in multivariate models there are two sets of modeling techniques, one is dependence, another one is interdependence, correct. But please keep in mind that these two will not be fully understood if you do not understand multivariate statistics, mainly the descriptive statistic part. Three things you have to understand here. These three things are multivariate normal distribution, descriptive statistics, and inferential statistics. Okay. And last, but that is also very, very important one is that prerequisite. Your prerequisite is basic statistics and I think linear algebra, that will be better. Okay. So, thank you very much. We will meet tomorrow again.